Hi everyone. This is a lesson on scientific notation. It was what we're going to be learning about in our session today. So let's go ahead and get started. So have you ever seen this on a calculator? 6.97000000E9. What the heck does that mean? Or how big is a water molecule? And you see an answer like this, 2.5 times 10 to the negative 10 meters. What does that even mean? Well, today in our lesson, you're going to learn how to write very large and very small numbers by using scientific notation. So let's review what we know about multiplying by the powers of 10. If I have this number 3.64 times 10, I look to that power of 10 and I ask myself, how many zeros does that 10 have? Because that is the key to moving the decimal. When we multiply by 10, we move the decimal in our numbers to the right, the same number of positions that we have for the same number of zeros that we have within our power of 10. So here I have 3.64 and I'm multiplying it by a power of 10. So what happens is that I move that decimal to the right one position because 10 has one zero and I'm left with 36.4. Now what if I do 3.64 times 100? Well, 100 has two zeros, so we can rewrite this as an exponent, 10 to the power of 2. It means 10 times 10, which gives us 100. So if we were to do 3.64 times 10 squared, or 10 to the power of 2, we'd be moving that decimal 2 positions to the right, to behind the 4, and we end up with 364. Now what if we have 3.64 times 10 to the 5th power? Wow. Well, we're going to take that decimal and move it 5 positions, right? 10 to the 5th. That 5 tells us how many positions we're moving our decimal. So let's see what happens. 3.64, moving that decimal 5 positions. It's going to bring us way past the 4. So what we do is we just fill in with zeros, like this, and we get the answer 364,000, just like that. Let's review some more of what we know about dividing by powers of 10, because this is key when we're writing small numbers. So if I have the number 3.64 and I times it by 3, like we just saw, we're moving that decimal to the right 3 positions, and we end up with 3,640. But when I do 3.64 divided by 10 squared, or 10 to the power of 2, I'm going to do something different with that decimal. I'm going to move it to the left because I'm dividing 2 positions because my exponent is a 2 here. And I end up with 0.0364. Of course, I fill in those empty spaces because I'm moving beyond the 3. I need to fill it in with a 0 in this case. Now, a common mistake that happens when people are trying to, decide how to move that decimal is they count the decimal places in the wrong direction. So here I have a really large number. I think this is 6,970,000,000. All right, that's a huge number. Sometimes what happens is that people will count the decimal from where it begins, right there. But really, we want to count the places that we need to move it, starting with where we want the decimal to go. So in this case, we want to put our decimal in between the 6 and the 9. So instead of starting at the orange decimal and counting forward, we need to start at this blue decimal and count backwards. So you count from where you want it to be back to where it is. All right? So let's take a look at our lesson today. Scientific notation is made up of 2 components. The first component is a number between 1 and 10. This is that 3.64. It's almost always a decimal of some sort. And it's only between the numbers, in this case, for right now, between 1 and 10. And then we have that times an integer or a power of 10. So a power of 10 that is an integer. It means it's a whole number. It's a power of 10, like 10, 100, 1,000, something like that. So some examples of numbers written in scientific notation would be these. 5.2, look, that's our number between 1 and 10, times our integer or our power of 10, which is 10 to the third power. We also have 8. Here's our number between 1 and 10. This isn't a decimal, but you could imagine this has a decimal, right? 8.0. Sure. Times 10 to the 9th power. That 9th power is going to tell us how many positions we need to move that decimal to the right. And then we have this one down at the bottom. 4.391 times 10 to the negative 2. We have a negative 2 power. I haven't quite told you what happens, but this is an example of scientific notation. So let's talk about positive and negative exponents. We know that a positive exponent is all about repeated multiplication, and a negative exponent is about repeated division. So if you see a negative exponent, it's like dividing by a power of 10 or dividing by the power of 10. So let's take a look at some examples. For a positive exponent, we have 5.2 times 10 to the third. We start with our 5.2. That's our number between 1 and 10, and then we move that decimal 3 positions, and we end up with 5,200. If we have a negative exponent, 5.2 times 10 to the negative 3, we start out with the 5.2, and we move our decimal in the opposite direction, going to the left as though we were dividing. And we end up with 0.0052, or this is 52 thousandths. All right. So positive exponent means we move our decimal to the right. A negative exponent means that we're moving our decimal to the left, just like we were multiplying or dividing by a power of 10. All right. So writing our large number in scientific notation, here it is. All right, we have that 6,970,000, and we want to write this in scientific notation. So first, we need to figure out where is the decimal. Well, it's right there at the end. Even it's invisible in this case. It's not really there, but we can consider it there, and we need to move it. This is where we're going to be moving it. So we want to put it right there between the 6 and the 9, because remember, our number needs to be between 1 and 10. So 6.97 is definitely between 1 and 10. So this is where we want our decimal to go. It's the blue one. The orange decimal is where it actually is. We need to count those positions, right? How many positions do you count? How many are we moving this decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9. I counted 9 positions. All right, let's see what happens. 6.97 times, there it goes, 10 to the 9th. All right, nice work. So this is how we would write 6,970,000,000. We'd write it as 6.97 times 10 to the 9th power. Now what about the reverse? What if we have a scientific notation number and we want to go to its regular notation? So we have 5.23 times 10 to the 4th, and this is what we want to write in our regular notation. So we begin with the 5.23, our number between 1 and 10. And we need to think about, okay, I've got 10 to the 4th. How am I moving my decimal? Well, we're going to move it to the right because it's a positive exponent, just like that. So So our answer ends up being 52,300 because we end up filling zeros right here. This is where our decimal lands, and this ends up being our answer. All right. So remember this number? I asked you, have you ever seen this on a calculator? What this really means is 6.97 times 10 to the 9th. Calculators don't quite or can't quite write 10 to the 9th power, so instead they use this E figure. So anytime you see an E and then a number after it, that consider E 10 times 10. All right, so 6.97 times 10 to the 9th. So this E, 9, really equals 10 to the 9th. All right. Now what about if we have small numbers? So I asked you, I told you a water molecule is about 0.0000000025 meters wide. Oh my gosh, that's so small. So let's see if we could write this number in scientific notation. Are you ready? Let's start with our number, 0.0000000025. All right. This is where we want our decimal to go, this orange spot. It's starting over there on the left. So here we go. It's going to bounce around. Boop, 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 boop. Did you count how many positions it was? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I counted 10. Let's see if we're correct. Yeah, 2.5 times 10 to the negative 10. So look, we were actually moving to the left, so in a negative position or a negative direction. So this is going to give our exponent a negative sign. All right, let's take a look at another one. We could think about the reverse. If we had a number written in scientific notation, how could we write it in regular notation? So let's take a look. We want to write 3.8 times 10 to the negative 4 in regular notation. So we start with that 3.8, and which way are we moving that decimal? To the left. Yeah, because this is a negative exponent. So we're going to move it to the left. There it is. We fill this in with zeros. And our answer ends up being 0.00038. So this is where our decimal would have landed, and there's our answer. All right, let's do some practice work together. On average, the sun is 150 million kilometers from Earth. Write this number in scientific notation. So I am going to write my number, 150 million, just like that. Sorry, this is messy. All right, our decimal is here, but we want it to be here. Remember, we want our number to be between 1 and 10. So let's count how many positions it takes. 1, 2, 3, 4, 5, 6, 7, 8. This would be 1.5 times 10 to the 8th power. That's our answer in scientific notation. Let's look at another one. Write 3.4 times 5 in regular notation. So let's start with our number 3.4. Our decimal is moving 5 positions to the right because it's a positive exponent. 1, 2, 3, 4, 5. I'm filling these in with zeros, and my decimal goes here. So I'm left with 0, 0, 0, comma, 0, 4, 3. I wrote it backwards to help me with my commas. So the answer of 3.4 times 10 to the 5th in regular notation is 340,000. Now let's go smaller. So a typical DNA molecule is about, wow, centimeters wide. Let's write this in scientific notation. All right, so 0.00000025. Did I get enough zeros? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, I did. All right, so we're starting our decimal here, but this is where we want it. So let's count. 1, 2, 3, 4, 5, 6, 7. Oops, you know what? I did the common mistake. I need to erase that. I need to start where I want it, right? And then work my way to where it is. 1, 2, 3, 4, 5, 6, 7. How about that? It ended up being the same. So we want 2.5 times 10, and this is negative 7 because we're moving our decimal to the left. So our answer ends up with a negative exponent. 2.5 times 10 to the negative 7. All right, let's take a look at another one. Write 3 times 10 to the negative 6 in regular notation. So we have the number 3, and we know that our decimal lives here. We want to move it negative 6. 1, 2, 3, 4, 5, 6. This is where we want it. We fill in with zeros, just like that, and we're left with 0.000003, just like that. Alright, so in our lesson today we learned how to write very large and very small numbers by using scientific notation. So this is how you can receive your content credit from me today. I have these 3 quick quiz questions. There are about 1,390,000,000 cubic kilometers of water on the planet. Write this number in scientific notation. Write 2.64 times 10 to the 8th in regular notation. And a typical grain of salt has a mass of 0.0000585 grams. Write this number in scientific notation. So we're going to go big, we're going to go small, and then we're going to go from scientific to regular notation. So take a moment, pause the recording, write or solve these 3 equations, or 3 problems I should say, and then send me your answers in a K-mail. Tomorrow we're going to practice this. So we'll practice more scientific notation, and then next week we're going to move scientific notation into common, maybe not every day, but common word problems that you could see on tasks within your curriculum or tasks within a test like the Oaks or something. All right, so that's our session today. Sorry we had tech issues. I hope you enjoyed the video. Bye, everybody. See you tomorrow, or see you next week.